All right, so like I have said before, that's my full name right there, Miracle Marcel. I am from Nigeria, and I am the Chief Scientific Officer at Pan African Citizen Science Lab. And in our organization, we carry out a number of projects, space science projects, and some of them are listed there. We organize them according to using different codes, like in Pascal Project 1.0. Here we talk about planetary defense. We contribute to planetary defense through helping NASA to hunt for dangerous asteroids in space before they land on Earth. They will also teach people how to process image of space, you know, from telescope. Then we have Project 3.0, which is web telescope usage. So I'm going to explain each of these projects and what we do in details. So under our Pascal Project 1.0, like I said, we have asteroid research, then we have space competitions, we have space arts. So focusing on the first one, I want to explain asteroids, what they mean, and why they are really dangerous to our lives here on Earth. So, about 5 billion years ago, the solar system was formed. So, after the formation, there were leftovers. Okay? The leftovers formed planets. However, not all of them could be able to form a planet. So, some of them were like debris, they were leftovers, and they clustered around this region called the asteroid belt. This red region called the asteroid belt, and we have the Kuiper belt. Okay, some of them also cluster there, but what you normally see here are comets. All the comets you hear about originate from this Kuiper belt, but asteroids originate from this region, this red region. These yellow concentric circles are orbits of larger planets like Jupiter, Neptune, and Saturn. Why these white concentric circles, or you can call them orbits, are orbits of inner planets like our Earth, Mars, Mercury, and Venus. Then in between that line is the asteroid belt. So, in theory, asteroids are about 1 billion pieces, 1 billion pieces. Okay, so but we have discovered 1 million of them, and we are still discovering. But one thing about this asteroid is that their orbit in this asteroid belt is quite stable. It's quite stable, but due to the enormous gravitational influence of Jupiter, this Jupiter here, on the orbit of this asteroid belt, they change their orbit, they change their direction of motion. So when they change their direction of motion, they might collide with themselves or collide with our planets or even these other ones that are here. They can collide with Mars, they can collide with our planet. Okay? So depending on the size, some of them are as big enough to destroy the planet. Some of them can destroy a city. So that is why they are quite dangerous, and it's very important for NASA to track these asteroids. And there are many of them, and because there are many of them, those working in the NASA industry cannot, they're not, their number is not enough to contribute to searching these asteroids. So they have opened it to the public to help to search for it, and also they are using it as part of education. So schools and organizations can incorporate it as part of their activities. I'm going to show you all of these things. So this is the asteroid. This is the simulation of the asteroid that we have discovered so far. So far, we have discovered up to 1 million. And most of these discoveries are from citizen scientists, ordinary people. You must not have a qualification in astronomy to be able to contribute. All you just need is interest in space. So look at what happened 66 million years ago during the days of the dinosaurs. Because they are animals, they do not have space program. They are only eating, reproducing, killing, dying. However, there was a bigger picture. They didn't know about these asteroids. So, because of what I just explained in the past, right now, the asteroid fell on Earth and destroyed all of them. All of them were all destroyed. So, of recent, in 1908, there was an asteroid impact in Russia. This area is the size of London, although not all of them is covered, but this area is the size of London. It's a very thick forest and the size of London. But when this asteroid landed in Tunguska, when it landed, it vaporized, like it turned the whole place to a desert. It is not even about killing the life forms like animals and destroying the tree, like just like it turned it into an automatic island. And this happened recently in Russia in 2013. Just during the daytime, an asteroid fell from the sky. And look at the simulation right here. It fell from the sky and it destroyed buildings. Although it did not land in a city, it landed in a very remote area, but the shock wave was able to reach the nearby city and destroyed buildings. And the shattered glasses, and the collapsing buildings wounded a lot of people. Although I think it's only 3 people that died, but about 1,500 people were injured. And the property that it destroyed was worth billions of US dollars. So you can imagine such incident. And recently, a man was in his home. So you can imagine you are just in your home and something fall from the sky and pierced through the ceiling. Look at that. And pierced through the ceiling and landed on the floor. So the man, just a man that is building coffin. Although he got in contact with the right sources, people that know the value of that mineral, iridium, he sold it for $2.5 million. Look at the size of that. So imagine if something will happen in Sudan like that. If people don't know about it, they will just don't know the gift. So the man sold it for $2.5 million. And this happened in 2022. It happened in 2022. So an asteroid fell in Europe. But before it fell, we have already discovered it few minutes before it landed, and we discovered that it is not going to pose any danger to Earth. This is a report from NASA. So there are many telescopes, space telescope. I mean, ground-based telescopes and space telescope observing the sky constantly and monitoring these asteroids for if there is any danger. They will plan on how to mitigate the situation. So these are some of the telescopes around the world searching for, scanning the sky for asteroids and taking images of the sky. So the data that we use, because in this work you don't need an observatory or telescope, we just analyze data. So the data you use are gotten from the Pan-STARRS telescope, from the Pan-STARRS. So, and here is the Pan-STARRS telescope here. So it is constantly scanning the sky. And once it scans the sky, the data, the images are sent to the International Astronomical Research Collaboration. So here, this is the organization that is responsible for assigning the data to different schools and organizations around the world. And we are registered with them. And here is the software that we use to search for the asteroid. It is called Astrometrica. These are the 4 images. 1, 2, 3, 4. This one is this. So it helps to simulate the 4 images. And what it helps to do is, if there's an asteroid that is moving, you can easily detect it, just like what is happening on the screen right now. So this is an asteroid, although this one has been discovered by other people. But this is how we basically identify asteroids. And we're going to train you on how to use this software. So this is our last campaign. Our last campaign. We have involved many people in Africa, mostly in the university level, space agencies, astronomy organizations across the length and breadth of Africa. We have reached up to 35 to 40 countries in Africa, and we haven't had participants from South Sudan. And I'm very glad that I have come across to you. This is Welcome to Pan-African Asteroid Search. So these are some of the countries in Africa that have participated. This is defined as places in Africa where we have trained people, like they have learned how to use the software to search for asteroids. Some of them have made discoveries. And here is our timetable. So for 2013, 2023, this is our timetable. So we have this one that is running from August and will end by next month 4th. And we have another one coming up on September 8th to October 4th. So we have these till December, and this is for 2024. So we have a lot of opportunity in our organization to include your team. And here are the requirements for participation. So you need a computer operating system, so a Windows operating system. It could be that Windows 7 all the way to Windows 11. You need a good internet connection. Then time commitment is about four hours per week. It is not something that will consume your time every day. So if you are very busy in your office or at school, maybe you are wondering why, maybe if you cannot participate in this program. You know, it's a program that is that can you can do without interfering in your work. You can do it at your pace. You need a minimum of about 3 to 5 people, sorry, 3 persons to form a group. 3 persons to form a group. I mean, we want teachers first, teachers that will disseminate the program to the country. We want those people first so that when they learn it, they can spread it. Then you also need passion for space and astronomy and discovery. So these are some of the discoveries that we have made so far. We've started this program in 2020, so getting to 3 years right now, and we have made up to 27 discoveries of asteroids. And one thing about this asteroid is that in the future you get to name it. So for now, it's going to bear this number. It's going to bear this number, the provisional number. But in the next 5 to 8 years, they're going to name the asteroid. So it is a very wonderful program. So you're not just doing it for NASA. You're not doing it for NASA. You are doing it for yourself and also to boost space science education and outreach in your country. So then we have another one. This is the end of the asteroid search. Then we have space competitions. We are working with this organization to spread astronomy competitions in Africa, the International Astronomy and Astrophysics Competition. Their program runs every year starting from February to June. So this is their website, this is their poster. So we have 2 categories. We have the junior under 18 and the youth above 18. And here are the 3 stages. We have the qualification round, the pre-final round, and the final round. So by the end of the program on June, the students that are participating might make it in the first or in the second or in the third. So it had different prizes. And we also sponsor some of our African students who are not able to cover the fee because after the qualification rounds, they are required to pay a fee of $9. So depending on our budget, we sponsor them so that because we want more Africans to participate in astronomy related activities. So this one is mostly for teachers in the secondary school and in the primary school. So here we inspire, we tell the teachers to tell the students to draw anything they can imagine about space. Anything they can imagine about space. So these are some of the arts we've collected from pupils and students in the past. So the age to participate is all ages below 16, and the organization responsible is Space for Art Foundation. This lady here is the one in charge. She's an astronaut, but she's a retired astronaut. Okay, astronauts are those people that travel to space for scientific research. So she's spending the rest of her life going around the world, inspiring children to pursue careers in STEM. So she's using her field space to inspire children. And when those arts are collected, they are used to build this kind of spacesuit. So this spacesuit contains artwork of children from all around the world. And sometimes the spacesuit is flown to the International Space Station. Look at the International Space Station here. And this is an astronaut wearing it. This is the International Space Station. In our work, I'm going to show you how to detect it here from your country. It goes around the Earth every 90 minutes, and it is like a star, but you will not even know it is International Space Station. So it's as big as two stadium. Then we have our second project. Our second project is Particular Project 2.0. Here we teach people how to process images from space gotten from this telescope. We use images gotten from this telescope. This is the Hubble Space Telescope. This is the Webb Space Telescopes, and this is the Los Commons Observatory. These are among the best telescopes you can ever uh, use in the world. And we're going to teach students and space scientists or space enthusiasts from your country how to process images of space. But before I move on, before I rush it, I want you to understand and appreciate the meaning of image processing. Look at my image here. This is me. Look at this is a camera. So I used my smartphone, okay, to take a picture of myself. And when I used it, I didn't have to process it further. Okay, it appeared the way it appeared as I took it. So right here you can see I'm wearing a I'm wearing a red tie, I'm wearing a white shirt, and this is my complexion, this is my hair, this is the whiteboard behind me, this is a camera. So both these two technologies can take my picture and I don't need to process it further. So because these two technologies have what we call color CCDs. So when you take a picture, you don't need to process them further. But the kind of camera we use to take images of space are not like this. We use a special camera called telescopes. So when you take an image of the space of this space with your telescope, this is what you're going to get: black and white. Sometimes completely dark. However, all the information you have taken about the object that you want is buried in this file. This file is called fit file. It is buried inside here. So it is your responsibility as an astronomer enthusiast or a professional astronomer to use special computer programs to extract all the all the information to produce vibrant images or visuals. And when you do that, you're going to produce beautiful images like this. So this is images of space that you usually see from the internet. When they are taken, they don't appear like this, they appear like this. So it is your job, which we will teach you, to turn it from black and white to beautiful colors like this. Then we have our project 3.0. So after you must have learned how to process your images, we will assign an account to you which you will use to schedule your own observation. Right there in your office, you can, if I give you the code, I give you access to this telescope, you can control it with your computer and schedule missions or images of any object of your choice. So when you do that, you also process it. So we have a telescope time, we have about 100 hours of telescope time with them, but we assign just 1 hour of observation time to each of our participants to enjoy. We also use it for research, for space research, because most universities in Africa do not have access to telescopes. So it's a very good opportunity to have access to this for research. So um, on the line, if you succeed in our project, we also donate telescopes from the Office of Astronomy for outreach. So that is the end of my presentation.